Today we're going to look at the emission spectra of some elements. When electrons around an element or an atom absorb energy, they go to what we call an excited state, which means they've gone to a higher energy quantum level. Okay? But they can't stay excited for very long, virtually instantaneous. They come back with what we call the ground state, their original state. So when they return to their original ground state, they emit electromagnetic radiation. Some of it we can see, some of it we can't. We're going to look at the ones we can see today, of course. So I have a number of different salts here that have different atoms that we're going to test. And so let's start. So let's start with barium. Barium chloride. There's a really bad joke about barium. What do you do with old dead chemists? You bury them. All right? So I have a little barium chloride solid here. I'm going to put it in the flame and we can see kind of a light green. And this is very characteristic, okay? This is very characteristic of atoms. These can actually be used to identify the elements in the compound. In fact, this is how they figure out what elements are on the sun and in outer space. So there was barium chloride. We'll go and look at strontium chloride now. We got a green, and now we have a nice red. That's strontium chloride. And these flame tests are often used in the field to quickly determine if chemists or scientists can determine what elements are present. We're going to do just simple table salt, sodium chloride. And you see the sparkles of yellow. If you've ever seen those street lamps that are bright yellow, they're sodium vapor lamps. They're doing the same thing, they're using electricity to excite the sodium ion. And sodium ion emits that yellow color. Let's take a look at its close relative, potassium chloride. This would be sodium-free salt. You can buy this at any grocery store. Okay, and if you look carefully, it's a little hard to see, but it gives off a purplish color. Let me get it going here. Look at the side right next to where my flame is. It's kind of purplish. There we go. That's potassium chloride. Let's take a look at boric acid. Boric acid can be bought in a hardware store. It's often used as an ant repellent. And you can see a faint green. There we go. Let's take a look at calcium chloride. This is often sold in pool supply stores. It increases hardness in a pool or a spa. We get kind of an orangey color here. And again, these are all unique to every element. Let's look at cobalt chloride. And it just sparkles like that. That's really pretty. Another use of these kind of colors is this is what makes the colors in fireworks. So you get to see these every 4th of July. And you often, at a wood stove store, you can often, or even at a Walmart, you can, in regular stores, you can buy stuff that will make colors in your fireplace. And that's what these are. Here's some copper chloride, copper 2 chloride. In a nice bluish green, very pretty. And last but not least, we'll do lithium. And it makes that beautiful, intense red. Now that's doing with solids. We can have a little more fun by dissolving these same salts into ethanol and then spraying them into the flame. So here's boric acid, and you can see it's very green. One of the reasons I got into chemistry, because I like colors. Here's our cobalt. Remember that kind of sparkle? Well, there it is again, bright sparkles. What do we have here? Potassium chloride. Let's see if we can get a little purple out of that. Not much. Little purple there. Here's calcium chloride. And there we got the orange for sure. Sodium chloride. Let's see if we get a little yellow. Yep, look at that yellow. Strontium chloride. Back to our red. We'll let that red burn off. Little barium chloride. Doesn't look as good as the solid did. Here's some copper chloride, copper 2 chloride, and we got our green there going. And last but not least, our lithium chloride. It makes that beautiful, deep red color. And that's the emission spectra of these respective elements that we tested, and pretty pretty.